Hello everyone, my name is Tarik. I'm a researcher at School of Architecture, Planning and Design at Mohammed VI Polytechnic University. First of all, I thank you to give me the chance to participate in ISEC 21 to present our work titled Thermal Behavior Evaluation of a Traditional Earthen Building under the Climatic Conditions of the Bengurir city, which is a relevant topic to the energy efficiency in building. This work is a part of research activities at our university in collaboration with the Material, Energy and Acoustics team at Higher School of Technology in Surrey. Without delay, allow me to present to you the plan of my presentation. First, we will put the project in its context by a general overview, as well as the objective of the study. We will then move on to the experimental and numerical study, and then discuss the results obtained, and we will end with a conclusion. As you know, the building sector is a very energy consuming sector. At the national level, it represents almost 33% of the energy consumption. However, it represents almost 8% of the national effort of mitigation of greenhouse gases. Hence, the interest in looking for alternative solutions in order to be able to contribute to this target. The main objective of this work is to evaluate the energy performance of the earth material of the city of Bengurir through the determination of the thermal properties by characterization and measurement methods. After that, perform dynamic thermal simulation on a case study. The earth on which we work is extracted from Bengurir city. It went through several stages to prepare three samples on which the two methods, hot flash method in a steady state regime and differential scanning calorimetry method have been carried out. As you can see in the picture, this shows the experimental setup of the stationary hot flash method, which gives us the ability to calculate thermal conductivity through this equation below. Several tests were carried out to find an average value of the conductivity with minimal error. Subsequently, and through the method of differential calorimetry, it was possible to estimate the specific heat by determining of the additional heat flow to be supplied to the sample to reach the temperature of the empty crucible. And finally, we found the following value. To be able to switch to dynamic thermal simulation, an analysis of the city's climate is essential. It gives us an idea on the climate, which is hot semi-arid climate with a maximum temperature in summer, which can exceed 45 degrees. The studied building is a traditional Xor-type construction hypothetically located in Bengurir city, unoccupied and without any other system of heating, air conditioning, and ventilation. By using Design Builder tool, the dynamic thermal simulation is carried out. The walls of the building studied were composed in such a way as to respect the traditional construction methods in the regions of Morocco by integrating the properties taken from the experimental study. The figure illustrates the results of the dynamic thermal simulation. For the question of thermal comfort, we note that the value of relative humidity remain within the comfort range. The analysis of the temperature profile for a winter period of 1 month shows that the thermal performance and the comfort conditions are improved to raise the interior temperature of the building to an average temperature of 18.72 degrees. We take the example of the month of July for the summer period, when the outside air temperatures can reach extreme values up to 45 degrees C. We note that thermal energy performances are not much improved. However, the absence of temperature fluctuations in hot waves is a good result, although the maximum indoor mean temperature reached 29.44 degrees C for this type of earthen construction, and the average temperature in this same period is reduced to 27 degrees C. To conclude, And given the above, we can say that the measurement method have many advantages, and earthen construction in the region studied presents good results for the winter period and less improved results for the summer period. Using passive solutions of bioclimatic architecture or energy efficiency measures can make the building energy efficient at all time of the year. Traditional earthen construction is a real opportunity to face the challenge of the century, which is climate change. Thank you for your attention.